What I want to do in this video is think about how different populations that share the same ecosystem can interact with each other and actually provide a feedback loop on each other. And there's many cases of this, but the most cited general example is the case when one population wants to eat another population. And so you have the predator population that likes to eat the prey. So you have a predator and prey interactions. I'm doing the prey in, I guess, a somewhat bloody color, I guess, because, well, they're going to be eaten. So let's just think about how these populations could interact. Let me draw a little chart here that you're probably familiar with by now, where we show how a population can change over time. So the horizontal axis is time, the vertical axis is population. And so let's just, in our starting point, let's say that our prey is starting out at a relatively high point. Let's say we're right there in time. And let's say for whatever reason our predator population is relatively low. So what do we think is going to happen here? Well, at this point, with a low density of predators, it's going to be much easier for them to find a meal, and it's going to be much easier for the prey to get caught. So since it's easier for the predators to find a meal, you can imagine their population starting to increase. But what's going to happen as their population is increasing? Well, it's going to be more likely that the prey is going to get caught. There's going to be more of their hunters around, more of the predators around. So that population is going to start decreasing, all the way to a point where if the population of the prey gets low enough, the predators are going to start having trouble finding food again, and so that their population might start to decrease. And as their population decreases, what's going to happen to the prey? Well, then there's going to be less predators around, so their population might start to increase. And so I think you see what's happening. The predator and prey, they can kind of form this cyclic interaction with each other. And what I've just drawn, this is often known as the predator-prey cycle. Now, to be clear, this predator-prey cycle is a simplified model. It's only taking into account the population of the prey and the population of the predators, but it doesn't take into account many other factors that would affect their populations: abiotic, non-living, and biotic factors, living factors, things like climate, resource abundance, or interaction with other species. For example, a drought could reduce the amount of food available for the prey species, and that could cause the prey population to decline regardless of what's happening with the predators. And I just reasoned through that you could imagine a world where you could have the cycle between predator and prey populations. But you can also run computer simulations that will show this, and even observational data out in the field also shows this. One of the often cited examples is interactions between the snowshoe hare, which would be the prey in this situation, and the Canadian lynx, which would be the predator in this situation. And you see a very similar cycle to what I just drew, kind of just reasoning through it. And this right here is actual data. You see the passage of time here, and this is a long passage of time. We're starting in the early 1800s, going all the way to the early mid-1900s. So it's roughly 100 years of data that we're showing. And in the vertical axis, you have thousands of animals, and we're plotting both the population of snowshoe hares and Canadian lynx in a certain area on this chart. And as you see, when the prey population is high, when the predator population is high, when we have a lot of the Canadian lynx around, that we see a lower population of the prey, of the hare. But then since you have a low population of the food in this situation, the predator population starts to decrease. So let me draw an arrow here. The predator population starts to decrease, and let me do that same blue color. So the predator population decreases, and as that predator population decreases, well, then the prey population increases because there's less folks around to hunt them. So the prey population increases. And you see that the other way around. When the prey population well, maybe we'll show it right over here. And this is real data, so it's not always super clean. But when the prey population is really, really high and the predator population is relatively low, well, then the predators say, hey, it's really easy for us to find meals right now. That was kind of that starting point in when I just was reasoning through it. And so their population starts, whoops, what did I do? Let me make sure. So their population starts to increase. And as the predator population increases, well, the prey population is going to decrease. So this is real data showing the snowshoe hare, the prey, and the Canadian lynx, the predator, on over many, many decades to show this predator-prey cycle. Now, I want to reiterate a point that I made earlier in this video, that even though we see this clear pattern between the snowshoe hare and lynx populations, remember that it's not just the number of lynx affecting the hare population, and it's not just the number of hares affecting the lynx population. There could be many other factors that affect both of these species, including other species. It could be non-living factors, their environment. For example, there's been research that indicates that the patterns in the snowshoe hare population are also influenced by stress and food availability, as you would guess, on top of predation by the lynx.